Okay, so in paper 2, you expect questions like this. Find the length of the length marked by an X in the following. So I decided to extract these questions from past papers, and then I decided to modify them a bit. I used an X instead of saying AB, but the procedure will still be the same. I didn't want to write so many questions or too many things. Okay, so by the way, throughout this lesson, these three lines here mean similar to. So when you have AB, 3 lines ACD, this means ABE is similar to ACD. So in your exams, this information will be stated. Okay, so find the length marked by an X in the following. So to solve such kind of a problem, the first thing you want to do is to separate the two similar triangles. So the first one here is ABE. So ABE. Draw it separately like this. So you have ABE. And then you can indicate the dimensions. This is 6. Then this is AB. We decided to call it X. So now the next triangle is this one is just on top of the other. So you want to get this as the next triangle. Remember, this is similar to this. Don't just get this one and remain with this. This does not make sense. This is not a triangle, it's a trapezium. So you get this one from there, and then you remain with ACD, which is the bigger triangle. Okay, so you can name it ACD, and then you can write down the dimensions. This one will be D. So by the way, in your exams, they will just ask you to find AB. This X may not be there. I'm the one who decided to use an X. So now this is 9 centimeters. This one AC is not 5 centimeters. 5 centimeters is the distance from B to C. If you are not sure, in the opening statement, you always have something like BC is equal to 5 centimeters. So this distance is the distance from A to C. So that means to get it, you need to add. Then, so this one will be the sum of AB and 5 centimeters, which is BC. So we normally write it as AB plus 5. Remember, the question is asking you to find AB, which is X. So the moment you write it like this, you never go wrong. So now, the next thing you want to do is relate the sides which are in proportion. So these are right angles, by the way. So as you can see, this side is the smaller version of this. So you can say BE is proportional to CD. And then next, this side here, which is AB, looks exactly like this. Like this is the smaller version of this. So you can say AB is proportional to AC. So now the other thing you need to be careful with here is when you decide to start with the smaller triangle, make sure that everything this side is coming from the smaller triangle, and then everything this side is coming from the bigger triangle, like this. So once you do this, it's just a matter of cross multiplication before you are done. So BE is 6 centimeters, and then CD is 9 centimeters, And then AB, you can either write it as X or you just leave it as AB. So I'll write it as AB. So if you decide to write it as X, make sure I write it as X even this side. So AB is related to AC, and AC is AB plus 5. Sorry, this is my 5. Sometimes it looks like an S. So now you can cross multiply from here, this by that. So 9 times AB, this is 9AB, and then you can have an equal sign there. And then 6 by this, you can write it as 6 multiplied by AB plus 5. So make sure you put the brackets here unless you want to expand right there and then. The other mistake which a lot of students make here is to just multiply this by this, leaving this one alone. So that's not correct. So you can say 9AB is equal to 6 times AB is 6AB. Then 6 times 5 is 30. So now you can collect the like terms and put them on one side. So it's much easier to take this guy to the other side than taking this one this side and this one this side, because that will introduce a lot of negative signs. It's not wrong, but it's just not the best option. So when this one goes to the other side, the sign changes to a negative. Then this is equal to 30. Then 9AB minus 6AB, this is 3AB, which is equal to 30. So now to find your AB, you have to divide both sides by 3. So that your AB is equal to 3 into 3 is 1, 3 into 0 is 0. Do not forget the units at the end. So AB is equal to 10 centimeters and you are done. So once you separate them, the rest is porridge. Let's try the next one. The next one is saying BCD is similar to, remember these three mean similar to, and CAD. So we have CAD. So you want to separate these two triangles like this. I'll start with my BCD and then I'll draw my CAD. This is my C. So it's supposed to be slightly bigger. CDA. So here we're trying to find DA, which is X. So we can put a 12 here. This is 4, this is also 4, then this is 6. So now let's relate the similar sides. So on this one, it may look a bit tricky, but it's not. So let me just draw it nicely. Okay, something like this. So to relate the sides, it's tempting to say this is related to this, but that's not correct. This is not related to this and this is not related to this. So to identify the related sides here, take note of this thing which looks like a right angle, and then observe the longest side on this triangle and the longest side on this triangle, the shortest side on this triangle and the shortest side on this triangle, the median sized dimension on this triangle and the median sized dimension on this triangle. So when you look at this triangle, the longest side is this BC. So BC is related to the longest side of this triangle here, which is AC. like this. So this is like the hypotenuse and this is like the hypotenuse. I haven't seen the actual past paper, but I think this may have been a 90 degrees angle. But whatever the case, it's still solvable. So next, you want to relate this side here, which is like the second longest side. So the second longest side here is DC. You relate it to the second longest side here. As you can see, this is not the second longest. The second longest is here. This is much clearer. As you can see, this is longer than this. So on this triangle, this is the second longest side, and then on this triangle, this is the second longest side. So this one, CD is related to DA, which is what we are trying to find. If at all this one was required, you would relate it to this one here, to DC, because this is the shortest side here, and so is this one here. So our BC is 6 centimeters, which is in proportional to AC, which is the longest side, this side. That's a 12. And then our DC is 4 centimeters, which is in proportional to DA or AD, which is what we are trying to find, like this. So now to solve this, all you need to do is cross multiply and simplify. So you can cross multiply this. 6 by AD is 6AD. Then you can put an equal sign and say 4 by 12, which is 48. Then to solve for AD, just divide both sides by 6, so that your AD is equal to 6 into 48 is it a 7? 8. That's an 8. So this one will be 8 centimeters, and you are done. So once you separate the similar sides according to the opening statement of the question, the rest will be very easy for you to do. So let's look at the last two questions or problems. So we have this one here. Then we are told that on this triangle ABC, which is the entire thing, is similar to triangle DBA. So you want to separate these two triangles. So I will do this. This is the bigger triangle. Make sure that you are drawing it as similar as possible to the actual drawing, so that relating the sides is much easier. And then DBA is like this. So remember, we have a right angle here, and then we also have a right angle here. I'm putting a right angle here because if this is a right angle and this is a straight line, then this one is also a right angle. So now let's name the sides for this one. So we have A, B, D. We are trying to find BD. So we know that this is 8, and then this one is 16. Okay, so as you can see, this is the hypotenuse or the longest side of this triangle, and so is this AB. So that means this is the smaller version of this. So to relate them, what you want to do is you can start with the smaller triangle or the bigger triangle. Whichever path you decide to take, make sure you maintain it. So I'll start with the smaller triangle. AB is, this is small to big. So AB is related to BC, and the reason is very simple. This is the hypotenuse of this triangle, and this is the hypotenuse of this triangle. Or this is the longest side of this triangle, and this is the longest side of this triangle. And then next, since we are trying to find BD, I'll write my BD here and relate it to the side which looks like BD on this triangle. So as you can see, BD is the shortest side of this triangle. So you relate it to the shortest side of this triangle. And you may not even need to use a ruler to see that the shortest side here is AB. But if you have to, you can still do that. Just make sure that you use the actual drawing to minimize mistakes. So next, you know that AB is 8 centimeters, so you can write an 8 here. Then BC is 16 centimeters, so you can write 16 here. Then BD, this is unknown. BD is unknown. You relate it to the shortest side of this, which is AB. AB is equally unknown. Actually, AB is 8 centimeters. This is the same as that. So you can write an 8 centimeters there. And then these are like fractions, so you can even reduce it here, but I don't want to confuse you. So I'll just cross multiply right there and then, and say this times this is 16BD. Then 8 by 8 is 64. And then if we divide both sides by 16, then BD will be 4 centimeters, and we are done. So once you separate for part D, DE is related to AB, and then AC is related to CE, and then DC is related to CB. So to see this, you can separate these two triangles if you want to, but I've decided to redraw this because I messed this one up. So to identify the related sides, just bear in mind that this is a Z. As you can see, these two angles are similar. These two lines are parallel. So this angle is exactly the same as this. So if I was to separate these two triangles, I would have the smaller one looking like this, with this angle similar to like this. A, B, this is 15, this is 10, this is C, this is 6, E, D, C. We are trying to find DC here. So as you can see, this side is similar to this. If I was to flip this one, it would be like this. This angle here would be here, and then D will be here, E will be here, C will still be there. So since this angle is the same as this one is related to this is related to that, and this is related to that. So I think it's much easier to look at it in this manner, because you can easily tell that DE is related to the parallel side, which is AB. And then next, CE, this one here, CE is related to AC like this. And then you can just substitute the numbers in. DE is unknown, so you can leave it as DE. Then AB is 15 centimeters. CE is 6 centimeters to AC which is 10 centimeters. So you can cross multiply this by this, will be 10 DE. Then 15 by 6, this should be a 90. Then when you divide both sides by 10, you have your DE as 9 centimeters, like this, and this solves the problem. So whenever you've been given a question like this, make sure you separate them first, and then you can relate the sides.